Hello and good evening. My name is Joshua Thomas, and this is my week 4 assignment, and this is a presentation on HIPAA and high-tech compliant ERP solutions. So I'm just going to go ahead and jump right in. So following the outline for a common and reliable ERP solution for electronic healthcare records, we see a lot of issues with security. A lot of cloud architectures get broken into. A lot of information gets accessed that shouldn't be accessed. Even the health.gov website that the Obama administration launched had multiple issues. And so we've learned from these mistakes, and going forward, we see that there's a correlation between privacy, and that's in security, that's where HIPAA comes into play, as well as high tech, which gives incentives to organizations to be compliant. And so following this architecture, we have the compliant electronic healthcare record at the center of it. Meanwhile, the development team will be communicating with the server as well as the EHR owner in order to deliver the best product. For our architecture, we will be utilizing AWS because it remains a cloud platform that is compliant with HIPAA and government regulations and is a trusted resource, as well as allows scalability and growth without impacting the financial budget. And we see here that also patients will be able to communicate with the EHR owner as well as their individual EHR records. And the technology in place that's at the front and center of the AWS model is the S3 bucket, which will be explained later on in this presentation. But the S3 bucket basically deals with it's a data source that holds the information that we will be utilizing for the electronic healthcare record in conjunction with the AWS servers. Going forward, the main methodology that will be used in constructing this architecture will be object-oriented programming. And that's because object-oriented programming is a paradigm that's evolved to really allow a lot of flexibility in models, because the programmers can then model and create objects as they see fit for what is appropriate for the architecture. So considering electronic healthcare records, there's a lot of data and a lot of information that's connected with each user. And therefore, no two patients are going to be the same. So object-oriented programming really is a great solution for these architectures. And going into that first, I would like to dive into the concept of encapsulation, which basically, in a sense, hides certain information from an object and allows you to use the methods of that object. So in this example, we have the public class person, which has a private string of the type. Private variable of type string. And so the private means it has restricted access. However, the getter and setter methods, which are public, which are get name and set name, can access the private string name. So we don't have to actually change that string for each person. We can actually set a new name and get a new name for each person. So this would be helpful in validating forms for users or patients when they first start a new EHR, or whether they're communicating with a different healthcare organization that's utilizing their EHR. It might be making a EMR, which is a electronic medical record, which is more of a record of individual event rather than a EHR, which is a huge snapshot of their entire health experience. The next aspect of object-oriented programming is inheritance. Inheritance, kind of like it sounds, it deals with parent classes and child classes. And what happens here is that if you have a parent class, you can actually extend that class to be a child class, and it can still utilize methods of the parent class. So for example, here we see that we have class patient. So that's the parent class. And it has a protected string, which is the level for the patient, the level of severity for their illness. And then we see that that function has a system.out print line method, which shows that the patient is checked in. Going forward, when you extend the patient, you have a class is ill. That class shows what the illness is. So in this instance, it's also a private string, which is the illness name. So in this example, we have the illness name being the flu. This is extended from the patient because this particular class is unique to the patient. Once we said not every patient is the same. So for example, one patient might also have the flu, but their severity might be high. And so it's important to be able to distinguish that to allow further functionality in programs in order to bring better service to the patients and to the healthcare professionals. Going forward, we have polymorphism, which means many forms. And so in object-oriented programming, what we do here is we have multiple classes that can take methods, and that one method can actually do many different things with just the one method. And what this is great for is within modern software architecture, we need reusability, because with procedural programming language, which we'll get into later, that runs from a top-down perspective. So every command in that code has to execute, which could actually slow the performance. And then the more users you have in a system, that actually it increments exponentially. So you definitely don't want that in larger systems. And so especially when in healthcare, when safety and people's lives are on the line. So with polymorphism, we have here once again, we see our patient class, which also holds the method for patient status. And we extend these classes to checked in and checked out. These are two other classes that extend from patient. And then they can also hold methods that show which patients are checked in and checked out. So for example, if you want to go into the patient class, and then you also want to go a little bit further, extend that to see who's checked in or checked out, you can also generate new objects that will show, okay, so if you create a checked in object, it will show Angelica, for example, she's our patient who's checked in, and that will print to the screen. Or if you create a checked out object, it will show that Brandon is checked out for our checked out statuses. And then you can refer to that method, the patient status method, and you can reuse that code over and over again. So you don't have to rewrite the code every single time you want a new patient is added. They just get added and you can update it. And the last aspect of object-oriented programming that we'll be covering in this training documentation is abstraction. Abstraction is similar to encapsulation, except for abstraction hides details, so it only shows relevant details, while also having the same methods. So you can also have abstract classes, and you could also have classes that extend from that abstract class. And you have abstract methods that are unique to that class, but could also be used within the program. So every patient will have the abstract method. It doesn't have a body. So the code is just saying this is the patient status that will be called, but it's able to utilize it. So once you use the patient status code in another child class, it's able to be used, but you don't see that initially. And so that's why it's important to be able to utilize this in classes. For example, you may have a feature in software where you may not always want every class to be fully visible, all its methods to be visible. So that's helpful for security and code reuse. And so going forward here, the difference between procedural and object-oriented programming languages, just quite frankly, deals with top-down approaches, featuring object-oriented approaches where you can actually call certain methods anywhere in a program. And then going on with our example of what exactly we want in this program, we have different data types that are used within electronic healthcare records. And these are features that could be extended. So this is why object-oriented programming is important, because it allows us to extend code and save data for use in the future, and it's scalable. And this is where AWS S3 bucket comes into play, where we can actually see these data types and how they correspond with emerging data types and how they can both be added to the AWS S3 bucket over time, and how that S3 bucket will correlate with our different aspects, different cloud components of our enterprise resource platform. So we'll be allowed to use mobile data and peripheral data such as iWatches and other peripherals that could be used, for example, heart monitors and everything else that a patient might have connected to them that can use an embedded device. Then, of course, we have the architecture of how we correlate with the patients and the doctors through AWS and Healthcare Organization, the app, which is JHealth, and our AWS partner service, along with the notion of speaking to an AWS consultant to make sure that we're within ROI metrics so that we don't spend too much money and the project does not go over budget. Also, so we can communicate cost to clients and patients to allow for competitive pricing is only just fair to them. And then once we have this, then we can also go into deploying and proof of concepts and implementation. And thank you for your time and have a great day.